Hey, Ashwat. One-on-one again.
Hi, Professor.
Hey. Nobody else here?
Nobody yet.
Yeah. Okay. So when are you going home?
I'm going home next Friday.
That's your finals week.
Yeah,
So
like
our
my
week 11
finals are.
is our week 11. That's our week 11.
Yeah.
So that's UCSB's week 12. Or are you?
That's UCSB's. UCSB is 10 weeks and then finals week. So it's 11 weeks.
Oh, 11 weeks. So and then oh, I see. So you're going to take the finals on campus and then go home.
Yeah.
That's cool because you'll have no UCSB work for our finals.
Yeah. Exactly. That's a good thing. Yeah.
That's great. Yeah, I think Ali's also at UCSB. Why? If you catch up with her, ask her why she's not absent in class. Because some of
Oh,
these
really?
things are going to be hard. She's at UCSB too, right? Because one time she said she had to go back to UCSB or something.
Oh, I'm not too sure. I don't know. If I see her, I'll
Well,
definitely
yeah,
let her
someone
know.
or any of you can reach out.
Yeah.
Not just Ali. There's a whole bunch of regulars who are missing, but and I think that it's a pity that if they miss out on the last couple of weeks, because that is really what prepares people to succeed in computer science and data science. Because you need to know link data structures. Everything up to now was just leading up to there, and if people say, well, I've got enough C++ before they reach linked list, that's like going all the way to the ice cream parlor and then saying, okay, I've come to my favorite place. Now I can go back home without buying anything.
Yeah.
Yeah. Hey, man. Better now? Well, your voice is gone.
He's muted.
Yeah.
Oh, hey, sorry.
I thought you still lost your voice.
Yeah, so the voice, you can still hear the voice a little bit, but it's better. Yeah, I'm doing a lot better now. Yeah.
Great. Welcome, Kai.
Morning.
Yeah. If you feel free to switch on the camera anytime soon, I hope. And then you were coding last class, and if you're comfortable with it, we can just continue with you coding, unless someone else wants to take over. Is that okay with you, Kai?
Yeah, that's fine.
Okay, cool. Not just now. Let's wait for other people to show up. And in the meanwhile, if you have any questions, I'm happy to answer them. Yeah. Regarding cs2a, regarding finals, maybe just wait until everybody's here. Concept level questions, or anything else you want to know about going further on into computer science, into cs2b level stuff, whether it's with me or at Foothill or somewhere else. If you're planning to go deeper into programming, right? And if you have any questions about that, you can ask me. And again, I think I mentioned this. I don't know whether I mentioned this to you guys or my 2B guys. Those of you who want to major in data engineering, data science, or machine learning, okay? The most important skill to have, other than a smattering of programming knowledge, you just need to know how to put things together and run things. But the most important skill to have are the skills you will develop in the empirical sciences. Okay, so if you study physics or chemistry, any of the empirical sciences, those are the skills you will need to succeed as a data engineer, not programming. Lots of people think it's programming. Okay, my take on this is that no, programming is just a way of getting where you want, but the data engineer needs to discern the pattern and say, hey, I can see a pattern. Can I try to repeat it? Can I try to control for it? Yes. Is this not what you do in science, in your science experiments? When you do any experiment, you got to control for all the other factors. Okay, isolate it so that you can see, okay, well, I've taken out all the distracting stuff and still I can see there's a pattern there. This electron is always spinning left, or something like that. Yes, after you control for everything. So that means you're training yourself to be a good empirical scientist. Empirical scientist means not, not solid in logic or math kind of thinking, but being able to isolate things and identify patterns. Now, a lot of people make the mistake in data engineering and data science saying, well, the best way to become a good data engineer is to start looking at lots and lots of data and look at patterns in data, right? But looking at patterns in data from experience, I can tell you, is like an order of magnitude more difficult than looking for patterns in nature. Okay, because looking for patterns in nature is something that comes to us instinctively. We're born with it, I think. Yes. Ever since we're born, we look for patterns in nature. We try to see what's predictable here. What, well, okay, that, seems to happen again and again. Okay, so we're trained, right? So science, empirical science, is essentially just taking that and fine-tuning that instinct and saying, let's look for patterns everywhere. Okay, anywhere that I have an instrument, whether it's my human eyes or a microscope or a telescope, an instrument that is capable of making an empirical measurement. Empirical means of this world, right? Anything that you can measure is empirical. So I say that anywhere I can make a measurement, I want to make sure, I want to try and see if there's a pattern in that measurement. So the next time I don't have to actually measure it, I can just use my pattern in my mind to calculate what it should be. Yes? Okay, so that is what science, physics, right? Lab sciences prepare you for. So any of you who want to be a data engineer, okay, let all the other guys slog it out over the data right now, because they're going to waste a lot of time. Because it's hard to learn and tune your, I think, right? Tune your apparatus, mental apparatus for finding patterns among the mush before you can tune it in, straightforward circumstances. So when the world presents to you so many opportunities to tune your scientific sense, use that, make your scientific sense as razor sharp as possible. Then if you go and look in data, which is a world of mush, okay, there's still data there, the pattern there, but patterns in data are harder to discern, okay? And I've told this to so many engineers I've hired before, okay, who go straight in and saying, okay, I'm going to look for, something there in the ones and zeros. Okay, but it is, and I can see there, it's very hard to discern these patterns. And so the best way to find out is to just see if you can tune your sense of finding. And that's why I say, accumulate more courses under your belt. Okay, if you're enrolled in a university or even at Foothill, if you want to major in data science, the courses you want to pick up, as many courses as possible, are the empirical science courses. Okay, even astronomy, talk to Jeff, right? Because you want to look at patterns of celestial events and say, well, there's a pattern, how can I explain it? Well, one pattern is that the earth goes around the sun, the other pattern is the sun goes around the earth. Okay, now how can I isolate things to make sure which one is correct? It's all scientific thinking, isn't it? Now, so again, in science, in any of the empirical sciences, I want to draw attention again to this fact that all of the professors have the same handicap I have, same handicap that some professor in math has, because the field is literally replete, uncountable numbers of things that can be taught. So many things there. Math proofs, computer algorithms, or empirical science experiments and patterns in nature. There's so many of them. So they have to pick and choose, and so so the goal in science, again, I don't even know if science instructors and teachers teach you this explicitly. Even PhD guys, right? So even PhD advisors I've seen, they teach you a particular way of doing things, and maybe they're trying to hope that that the sense will blossom in the student after doing all of this, right? But I think that just mentioning to the student early on that this is what I'm trying to do, okay? I'm not trying to get you to master this particular technique, but the technique is a tool to help you find a sense, to identify patterns yourself, okay? If they tell you that, if they tell you that, I think it goes a very, very long way. Any instructor, okay? So so in your science experiments, you're doing a lot of these things, discovering pendulum periods, or the spectrogram analysis and things like that, experiments. And the goal, again, is even if the instructor fails to tell you, is not for you to master that particular technique, but basically look at what's behind the technique. What are they trying to get at? What is it that you're trying to tease out? Okay, and then after having teased out 10 or 100 different things, then you'll have that tease out sense ingrained in your head. And then everywhere you look, you're going to say, is there a pattern there? I'm going to kind of tease it out, right? So, and so on. And then with that mindset, even with a smattering of programming knowledge, you would be a high value data hire, okay? Any person anywhere in the world will be glad and happy and fortunate to have you as a data engineer, because they know if they can throw mush at you, you know how to control for it and say, well, you know what, this is all wind blowing in random directions, so I got to go into an isolated room. That, decisions you make in science, you're going to make in data engineering too. But if you don't you train yourself to make these decisions in science, you're never going to make those decisions in data engineering. So, so that is why, I say those of you who are majoring in data engineering, just pick up a smattering of programming knowledge, learn about the power of programming, certainly about linked lists and trees and so on, because those are going to be your tools. But that's not the end all for you, because you've chosen, I think, or your interest at that point anyway, say that, you're more of an empirical scientist, right? You want to discover things about this world rather than about logic and mental constructs that you can say are guaranteed to be true no matter what. Okay, but these are most likely true as far as we know, science. So so once you've made up your mind where your interest lies, your principal interest lies, then you can say that's where I want to focus all my courses on. Okay, so if you're going to be thinking about the these things, then say, well, I'll do as many science and measurement things. Okay, everything that requires measurements and precise measurements, right? Those are things you need to be really, really good at, because the art of measuring things is what you need to be good at in order to be successful in data science and data engineering, right? Because data science and data engineering are not mathematical sciences, right? They're probabilistic sciences, in that sense, you can say it's statistical, but really they are of this world. So once we've made up our mind, so we know what courses to select. All right, so I think, there's only a few of us now. I don't know, Kaylee's joining late. Someone's got to reach out to her and say, okay, come sooner to class. Who else is missing? Noah is also joining late. Fernando, especially because, he's trying to make progress on some of these quests. You guys should also help each other, okay? And I'm glad to see some progress. I think all of you will pass, but you got to seal in your grades if you're interested in it, and make sure your quest scores are being reflected in the /Q site. If you're on the /Q site, I'm pretty sure, right? 99.9999, right? So those scores will get transferred to Canvas, but some of you are missing scores in Canvas, okay? And I'm mentioning this because I'm surprised, because and I see you in class and I say, well, these guys should know this stuff, okay? But why aren't they getting these points? Easy to get points. So so that leads me to two conclusions. One is that's what I told Noah too. Maybe you're doing this course for fun. Perfectly fine reason. And in fact, I'm happy with that, right? That is my personally best reason, right? I'm doing this course for fun, to enjoy it with everybody else, right? So I don't care if your scores don't get employed, you're not concerned about this, but you still, you can get to submit all your quests without your student ID too. That's fine. Or you could say, yeah, well, is that the only reason for not caring about your Canvas grades? I think so. Or you could say, yeah, well, I know I'm missing those scores, but I'm racing ahead to quest 9 and get all my scores. Okay, so that's also a valid point. Yeah, if you finish quest 9, you can go and, every quest is unlocked at that point. You can go and get points on any quest, even the extra credit ones that you missed out before. Just go and grab all those extra points. Even if you cross the ceiling, I know people who've crossed 180, because 180 is our cap. Any trophies you get more than 180 don't really count for your grade. But I know people in the past who just said, okay, I want to get all 190. So yeah, so you can go back and get all the points if you want. So this
Professor, are you familiar with Visual Studios?
Hmm?
The IDE Visual Studios.
Visual Studio.
Yeah.
Yeah. What about Visual Studio?
I just, with the help of some tutors, I just downloaded it and
Oh, you mean VS Code or Visual Studio?
Visual Studio.
Oh, wow. So you're downloading the entire compiler package?
Yep. Yeah. I tried using VS Code, but it's been an ongoing 10-week battle with me and the tutors to try and get that thing up and working for me.
Wow, that is so strange. That is so strange. Well, as far as Visual Studio VS Code goes, maybe our tutors are less experienced because they are used to VS Code and Visual Studio Code and Xcode, mostly, I think. But our students, your classmates, have a lot more experience with Visual Studio Code. And I know that Lane Johnson has a lot of experience with VS Code, okay?
Yeah.
So I think that by installing Visual Studio Code, you're probably regressing a step back, okay? Because I know many of my friends, even in Microsoft, they're using, even if they're using the command line Microsoft compiler in the backend, right? They're using it like MinGW or G++ and using VS Code on the front end. So I think that, and maybe the reason for that is because Visual Studio Code is such a heavy duty program, right? Even downloading it takes like 1 hour.
Yeah.
And then there's licenses you have to click through and packages you have to install, various different packages. And it's almost become like a language of its own.
Yeah. No, I had to download, I did MinGW, I did Video Studio's code, obviously, so just connecting all the bits. I was doing a lot of
No, I would highly recommend that you just go the VS Code route, even if it's more challenging right now. Find out people and Stack Overflow or online or your friends who use VS Code and get really solid with VS Code.
Right. No, I should, but with time crunch and everything, and
there's no time crunch. Well, which quest are you on?
Oh, right now I'm on quest 5. I haven't been able to use anything to continue coding, and so I've kind of took a 2-week hiatus.
Okay, how about this? Okay, after class, try and get together with someone in class. I'll try and remind me and make
it's really no worries because
G++. Sean, I think had Sean, did you have a min G++ or something going before? I remember talking about that in a very early class.
I'm not using VS Code or anything. I mean, I kind of am, but I'm not compiling it on there. I'm just doing it on online GDB, and then I'm saving it on the VS Code, and then I'm just doing it from there. Because
all right.
Okay, so I'm using
everybody has to get used
Visual
to
Studios.
Because online GDB is not going to help you after quest 8.
Okay. I mean, I kind of know how to compile on there, but I'm like a special case because I'm using a Chromebook. So it's like a lot different. Yeah. So there's like a specific way to do it with a Chromebook. I looked it up. I've like compiled it on there a couple times. So I like kind of know.
Yeah, and you don't have access to a laptop anywhere else?
I don't. So I would have to buy a new one if I'm gonna like.
Okay, and even if you manage to do it in a library, yeah, I think a laptop would be a good investment personally.
Yeah, I'm saving up right now.
Yeah.
So my question was
online GDB. I was just mentally in my mind.
Visual
Okay,
Studios.
I was debugging quest number 9 in online GDB, and I can tell you, okay, that's not something I'm going to look forward to doing, right? Because online GDB, the way you would debug quest 9 is by printing out cout statements, and well, you got to be really, really lucky and also extremely experienced. Okay, you can use online GDB to debug your quest 9 and advanced C++ programs, but in order to do that, you got to be a very experienced programmer. Okay, the reason I say that is because I think Kernighan or one of those C++ guys, he said, and I found a lot of truths to what he said. He said, the best debugger you can ever use is a print statement. Okay, so we have all these sophisticated graphical GUIs and debuggers saying, wow, okay, this is what is happening in this chunk of memory in your program and things like that. But he actually made a very insightful comment many years ago when I read that, and I thought, wow, what a fantastic comment. Because at the end of the day, if you know what your program is doing, and like a good scientist, you've narrowed it down to saying, okay, the program has to be doing something wonky in these 3 lines. Okay, that's what we do, right, as programmers? Most of the time we narrow it down visually to some chunk of code and say, this is where the problem is happening. Yes.
Mm.
Okay. And so we say, wow, Kayla, you got a lot of organic chemistry on that. Wait, which way is this? Is this the corner room in the PSEC building?
Yeah, the conference.
Oh yeah, the corner room. Yeah, I remember. It's 2 big windows on the other side and all.
Yeah.
Yeah, nice. Yeah, that's where we used to have our curriculum committee meetings. So I guess Ron or Kathy is using this now for teaching some of our students. Okay, all right, cool. Anyway, what was I saying? Jan, damn, I lost my train of thought. VS Code. We started talking about Visual Studio Code and VS Code. Hey, does anybody remember what I was talking about, or you were basically all tuned out anyway?
Right. I had a question. I'm trying to get Visual Studios to work, and I was hoping for you to help me with that.
Yeah. All right. So do whatever you think is going to be good for you and easy for you.
Yeah.
Yeah.
So I'm using Visual Studios.
Oh yes. Now I remember. I got my train of thought back.
Man, you have Windows
Debugging
or
Quest 9.
Mac, or what do you have?
I've got a Windows. Yeah. So I'm using Windows.
Okay,
Visual Studios.
I think it should be fairly easy with Windows. I don't have Windows, but like, I think it should be fairly easy to look up. I think you like download, like main GW, like Professor said.
Oh, not Visual Studios Code. I'm using just Visual Studios, the IDE, which I've already gotten downloaded and everything, and I've been messing around for the past couple of days.
I see.
If you can get it to
So you've given up on VS Code?
Yeah, I've given up on VS Code. It's much easier to use Visual Studios, especially with the beginner class that we're in and everything. VS Code is going to way down the road a lot better, but it's been taking too much time. And the tutors, only Lane Johnson knows what to do. And it's just to sync up with his schedule is kind of a little bit rough because all the people go and wait in line for his tutoring session. So I get like 20 minutes after like a
is that it?
Yeah, so it's a lot. So is it okay if before we start the class, can I screen share and you can help me connect some file paths?
Well, no, I didn't realize that nobody's getting his time.
Yes, it's pretty good.
Okay.
Can I screen share?
Yeah, you can screen share. Totally.
Okay, perfect. Okay.
But you can use Visual Studio. Everyone in all the tutors in the STEM Center know how to use Visual Studio and go with that. In fact, hey Van, why don't we code with you in Visual Studio today? Because I'll try and remember what I need to. I remember. I used to use Visual Studio a very, very, very long time ago. Maybe it's changed like many generations after that. But I'm pretty sure they'll keep the core functionality together. So I can walk you through this.
Okay. So first thing here we got is I opened up a project, and in the project we have the main, and that's I just called it Quest 5 because I was trying to get it to work for Quest 5.
All right, no, kill it all. Let's just start today's code. Just create a project create a project called 10th May or something like it, March 10 or something like that, and then in that project, let's create add a CPP file called main.cpp, and we'll do everything inside of our main.cpp. No, don't change Quest 5. That's your Quest code. Don't kill the buffer. New project, yeah. And then close your Quest 5 code altogether. Hit X on that thing. Empty project. Yeah, console app is what we want. Yes, exactly. And did you click C++ on the previous screen? I think you have to. I didn't see C++ clicked. Click black. Click.
Oh no, it's C++.
Oh, there you go. Yeah. Okay. C++ Windows console. Oh, I see. I thought there were 3 languages. C++ Windows and console. Okay. Yeah, March. Actually, just say it's March 10 and 1. Just give it. No, don't put any spaces or commas. I don't know. I don't know how Windows does these things now. No. Just say no. You can't. Oh, there you go. No slashes. Okay. MAR10. MAR10. That's it. You can have a hyphen there. I think that's fine. Yeah, okay. All right. Source repos. You're putting in repos solution. Okay. And March 10. That's the name of the solution. Yeah. Okay. Yay! Cool. All right. Create.
There we go.
Oh, it created a file called mark10.cpp with a main. Okay. So it's all right. Cool. When you build, that's fine. Okay.
Yeah.
What I thought would happen was that it'll create a folder called mark10, and inside of that you'll find main.cpp. But it doesn't matter. It basically created a folder somewhere, okay, and in that it created a mark10.cpp, which in fact has your main in it. Does that make sense? Okay. Hey, others of you who are not using Visual Studio Code, it's all going to be pretty much the same. And we are at this point pretty much we're going to start working on linked lists right now. Essentially continuing on from what we did before with, hey, Kai, let's not even bring your old code, okay? Where's Kai? Oh, all right, he's gone. Yeah, we'll just leave that alone, okay? We'll just put everything together from scratch because it's also practice and quite easy for us, okay? So tips for getting started. Oh, I see. It's given us a bunch of helpful tips right there. That's nice. Okay, all right.
A couple of things that aren't there. So I tried to just create multiple files, and let's see if I can.
Oh, where's your package explorer? Oh, it's on this side. It's on this side.
Yeah. What is that? Oh, a package explorer.
Yeah. So that's your March 10 package, and inside of that you will have that folder called source files.
Yeah.
Click that, and you should see Mark 10. You see that's the file you're editing right now.
Right. So
I've
what we
want to do
is
just use Mark 10.cpp. That's fine. That's your folder, March 10. I've forgotten this way of doing things. Okay, so go to just compile and run it now, and make sure we get hello world because that's our template. Yes.
Yes.
Yeah. Okay.
What's it? Oh yeah. So
in fact, you can hit the green triangle. Hit the green triangle. I think that's a run. Oh, local Windows debugger. No, we don't want to debug it. Run without debugging. Is there an option to run without debugging?
Oh, I don't know. I just started.
All right, then doesn't matter. Doesn't matter. Yeah, okay, it's working. Okay, so it actually compiled and ran with. So pity doesn't show us the compile line. So you know, even though it does it in the background, it'd be nice if it showed us the complete path that it used to compile it, saying, you know, Microsoft C++ -O and so on and so forth. But where did it put the binary? It ran the binary, but where did it put the binary? March 10, external dependencies, solution. Where's the exe file? I don't see the exe file in the package explorer. I don't see the exe file in the package explorer. Where did it put the? No, that can't. It can't be there. It can't be there. No, it's gotta be. Well, anyway, it's put it there somewhere. Okay, you can find out. You can always, you know, right click and say locate in Explorer, things like that, and we can find out. But let's not waste time on it right now because we know it runs. All we are interested in is in the code and the output, the behavior, which we'll see in that console when you run it, right? Because that's all we need. Yes, to understand what the code does. And the rest of it you can basically figure out by going into Windows Explorer, you know, just Google and say, well, you know, what is the structure of the project folder in Visual Studio Code, right? And it'll tell you. Okay, so what we're trying to do? All right, so let's now create a class above int main. So above int main after in hash include IO stream. And in fact, let's say using namespace so that we don't have to worry about doing std : like they've done. Yeah. All right. Okay. So on the next line, you say class node, a couple of blank lines after that. Yeah, a couple of blank lines and say class node with a capital N.
Okay. You said node, NODE.
NODE. And then space open brace. Open brace and hit enter.
Brace.
Yeah, hit enter.
Right.
Oh, that's cool. That's cool. See, you also gave you the autocomplete with the semicolon at the end of the closing brace. Yeah, I think online GDB didn't do that, if I'm not mistaken. On Tuesday when Kai was coding, when he created the node class, it gave him the closing brace, but it didn't give him the semicolon. That's really cool. I wonder if VS Code should do it, obviously, because if VS Code doesn't do it, see, that's the cool thing. Even here you can do it. But in VS Code, if you see that it's not happening, you can actually go into the config file and make it happen the very next time you invoke it, because it's just basically a change, right? And even you can do that even in Visual Studio Code, but you know, that's all been made much easier in VS Code, I think. I'm plugging for VS Code, having never used it so much myself. Okay, so just because I see the joy of of all the other people that use it, right? Because a lot of my students use VS Code and they're able to do things a lot, very easily and smoothly in 2B and 2C, and so I think that it is something. And also I think my son started using VS Code and he's very enthusiastic about it. So that's really cool. So I think that's cool. All right, so class node, yeah, we're going to say all public, okay? So just say public, public colon, and on the next line. And the colon should take it all the way to the left. Let's see. Put a colon there. Immediately after public, put a colon. No, not semicolon.
Colon. Okay, gotcha.
There you go. All right, so yeah. All right, so when you hit the colon, it went all the way to the left because it's a conventional indentation. Right, because if it's a int, if you're going to say int data, it won't be there, right? It'll be indented in. It's part of the class. But programmers have public and private and all these tags indented with the class name. And so when you put the colon, it went all the way there. So that's very nice. Okay, on the next line, now you can indent in. So it's already indented for you. So we say int data, and then next line, and you want a pointer to an object of class node. So you're going to say node, N-O-D-E, uppercase, sorry, uppercase N-O-D-E, yeah, space, that's a star, next.
Star.
Shift 8.
Like,
No, shift 8.
Shift A.
Shift 8, yeah, 8.
Oh, 8. Oh, star.
Shift 8. Next. That's it. All right, that is our linked list node. Okay, that is a single node in our linked list, right? Semicolon, and you can put a comment above line 7 that says this is our this is a single node. This defines a single node in our linked list. And let's go to our main now. And in our main, let's say node space n1 comma n2 comma n3, right? So we're going to create 3 nodes. Yeah. Okay, now here's a cool thing. Enter and get rid of the cout hello world because we're going to do our own stuff now. And put a return 0. It's good practice there. Yeah, put a return 0. No, not there. Yeah, there. Return 0. Yeah, if it fixes spelling. No, return, R-E-T-U. Yeah. 1. Okay, there you go. All right, now, so node N1, N2, N3. What we want to do is hit a couple of blank lines there. And then on line 18, put a comment saying, let's link up N1, arrow N2. Wow, what did it do?
I just did a triple. I don't know what that means.
Oh, you did a triple, you did 3 things there?
I did 3, yeah.
Oh, maybe that's a new convention in documentation. I don't know. Maybe, yeah, it's quite possible that's a new convention. All right. Yeah. So
what was it?
What did I say? Yeah, link up. No, that's fine. Link up the nodes into a list, like N1 arrow N2 arrow N3.
Do you guys want my code from last?
Arrow. You can say arrow. Whatever you want.
What was that,
right?
Kai?
Do you guys want my code from last class?
You can say a couple of dashes. You just want to say N1, N2, N3 in some sequence. N1.
And then
arrow
is if you want to use the code that he has from last class.
Yeah, this is just a comment. You don't have to put it in. Yeah, this is all right. Just say N1.
Oh no. Kai's asking if we want to use the code from his.
No. It's okay, Kai. You were off screen when I mentioned that.
Okay.
I said, yeah, okay. Let's just go and do it anyway because it's very simple, right? It'll just get us in the more in the practice of doing this repeatedly. This is something we have to do.
Okay.
Thanks,
so sorry.
Thank you. I'm sorry, I didn't hear. Listen to what you were saying. Okay, Van, you were saying something?
Oh no, it's okay. I was just saying. Oh man, I forgot what we were talking about. The comments. What was it that you were saying?
Yeah, say hyphen hyphen greater than, all right, hyphen greater than or something like that, hyphen greater than.
So link up nodes in a list.
N1 to N2 to N3. N2, yeah, let's just say 2. N1 to N2 to N3. N1 space TO.
To
N1, N2 space to N3.
Oh.
To nothing. So finally say to nothing, because and the nothing says that's the end. The nothing says there's nothing following N3. On the next line you can say, nothing is the nothing is there to tell us there's nothing following N3. Is everybody okay with this so far? Hey, June, welcome to class. Giovanni, you were there before. You were on camera before, you just switched off. So, yeah, okay. June, are you there?
Yes, Professor. Yeah.
Great. Okay, all right. So is everybody okay with this so far? Now, what I'm going to do is just link up N2 to N3. Can you guys do the rest? Well, in the process, let's also put some numbers in there. Okay. So let's say on the next line, on the next line, you say N1. No comment. You can actually say N1.
Okay.
N1 dot data equals. Let's say 10. Okay, 10, 20, 30. 10, 20, 30. All right. Now you can also say N2 dot data equals 20, N3 dot data equals 30. So let's put data in all 3 nodes.
Okay.
Well, technically these should be above the comment, right? Because the linking up comes after, but we can fix that later. Can you take the 3 green comments and bring them below the data assignments so that now we're going to do the linking in? Is everybody following? Okay. So I don't want Van and I to be the only people typing. Kai probably typed all this already last class, so he's kind of following along, but I don't want to lose anyone here. Is everybody okay with what we're doing so far? If we're doing it too slow or too fast, you should tell me. Okay. All right. Cool. All right. Next. Yeah. So on the next line, what we're going to do is N1 dot next equals address of N2. How are we going to get address of N2? The place where N2 is stored in memory, the house number, the place where N2 lives in memory, the specific byte number. How do you get that?
N2 dot address?
No. You can't get that in any other language. Okay. That's why.
I wish.
Yeah. So that's C++ here. So you want the memory address, the physical location on your phone, right? With many gigabytes of memory. You want to know the exact transistor. Which transistor is it? 4,742nd transistor. You want that level of detail. What other than assembler, you can get that here in C++. And C++ tells you I can tell you the exact set of transistors, the exact set of physical circuitry that is responsible for the next instruction. You just put the ampersand sign in front of the variable. I'll tell you where it lives in memory. Okay, that's all. Okay, that is called the address of operator. It is the most powerful operator in C++. Address of. Okay, this is how it's got a counterpart saying contents of. Okay, but those are the 2. Right, so address of N2.
Just N2 or dot?
That's it. That is the place where N2 is stored in memory. How cool is that? Okay, in seven characters, 7 letters on screen, that encapsulates a vast universe of power of C++ right there on that line. But you got to get really solid with that, saying, well, it's just the address of operator. I can use it on anything. I can use the address of operator on anything, on functions, on anything, right? Because everything in a computer is stored somewhere. Yes, whether it's programmed to be executed or data to be processed, it's all stored somewhere. Yes. So in C++, you can get the address of anything, which is so cool, and which is also, malicious hackers sometimes exploit this, and they say, well, because in C++ I can access any address in memory, let me write a program which through some clever will access its own place in memory or locations in memory where program actually lives. And I am able to edit those. So it will change the logic of running programs on your computer. You can have a virus that will change the way in which your operating system itself behaves. Well, technically it's not possible because there's so many, the OS guys are clued up to all this. So they have all these safeguards built in, okay? So it's not possible some random hacker to get into your OS and change the way it behaves. Especially for exposed servers like Google and web servers out there. I go to the questing system and I see every day, there's like tons and tons of people trying to break in, right? Because any system that's exposed with a public IP, you can get it, you can say, and let me try and hack it to see if they have WordPress installed, if they have something installed that will let me run my programs there for free, okay? And there's a whole industry devoted to this. Just like you're mining coal and copper and things like that, there is a whole new ecosystem of people who are mining the internet for free cycles. Okay, this is like 21st century mining, yes? Because there are people that basically say, what are all the IP addresses and sockets that are reachable on the net? How many of those can I, because in order to discover those, you got to put some electricity, because you got to run your own program and probe and everything. So it's going to take some electricity on your, right? So it's exactly the same kind of reasoning that all these mining companies in Australia and all these people, Brazil, same kind of reasoning. They say, okay, this is the amount of resources I can bring to bear on determining what IP addresses, hosts are reliable and usable for running my list server, my chain letter scan, my Visa card analyzing thing, right? So they know, all right, it's going to cost me, I don't know, $4,300,000 to do that if I set up this infrastructure in a cloud. However, I stand to gain 83,042,000 if this works on average. Okay, so it's worth a shot. Bam. So that's a mining operation. Yes.
Yeah.
So you can be, so that's a totally new form of mining. Most of the people are just stuck in the old days, digging things out and shipping it up, because it's a completely new ecosystem out there where the true power comes from the operations. Okay, so all right, so do you guys want to do N2s next and N3s next, because those are also important? Okay, once you do that, I will show you one other method we need to do, and then we can have a great deal of fun. Okay, and then for N3, someone else, not the van, is typing in N2, and someone else hopefully will tell us what N3 should be. Right, the next line. No, go ahead, Van, complete your line, and then the next line is the next line, someone else has to tell me what the next line has to be. Come on, take a stab, okay? I'm taking so many chances in class, your class, any class, really. Anytime I'm online like this, I'm just saying whatever I think.
The semicolon?
Hmm?
Would it be just the semicolon?
Okay, that's a good guess. Okay. No. In fact, technically that should be possible, right? You can have a C++ compiler that says in this context you can put it. No, but they didn't do it. So, all right. So good guess, Sean. What else? Kai probably knows the answer because he did it, okay? And he's not speaking up, which is okay because he already did it. Someone else should say what it should be. Next
What
line.
about pointing N3 next back into itself?
Into itself?
Who said that?
Me. N3 back
Giovanni.
into itself.
All right, that is actually very good. That is a very good sentinel, not the best, okay? It is a good sentinel. I can say it's not the best one because it kind of disallows self loops. Yes, because you can say that anytime you encounter a self loop, that's the end of a list. Because the way that Giovanni has imagined this in his head is that a list is like, like that thing. And then when you get to the end, it's going to curl over like that. That's the end. Okay, so you can have a linked list of items. And the last one is basically going to point to itself. So there's no risk of pointing somewhere else. So let's, before we move on from that, we just need to appreciate that that is a fantastic solution to this problem. Okay, so if you ask someone an intelligent child, for example, right? Intelligent, how can you solve this problem? And they haven't read it on the internet already. They haven't been told what to do by other people who've tried this before. Okay, this is the exact answer you can expect from an intelligent person, right? To say, well, there's many ways you can do this, but one of the ways you can do this is basically go to the end and then cut it up, right? So the disadvantage with that is that, although that's a fantastic approach, the disadvantage is that there is a small catch that I cannot have a list with a self loop, right? Maybe a self loop is actually a valid structure you need. Yeah. So, and also when you go to other structures, lists, trees, for example, you may need to have a self loop, a graph, for example, a self loop, and then more nodes from there. So these things will kind of start getting messier. So let's see if we can find another sentinel. Okay, not a self loop, which is a good sentinel, but it could be messy. Another sentinel. Okay, the sentinel is something that is basically a signal to us. A sentinel is a signal that says what you're looking for is not there. It's a 404 page. You guys have got 404 pages? Yeah, your page doesn't exist. So a sentinel is a 404 page in your linked list, or any data item that you're processing, a collection of data items. When you hit a sentinel that says this is a data item which is legal, but we have agreed that it's not going to be legal, and it's we coded it off. So anytime you hit this data item, that means that you've run out. That is what a sentinel is. It's a fancy word, sentinel. That's what it means. It's a legally cordoned off value. Okay, a cordoned off legal value that we can assume to be not present in the rest of the data, which means that if you see it, there's something wacky, right? So you're trying to signal something. So that's what a sentinel is. A sentinel is a signal. So far, are we okay? Unless some of you say, yes, I'm not moving on from here, okay? Are we okay? We need a sentinel that says this is the end of the list. Giovanni gave us a very good sentinel saying that we will basically say that n3.next equals address of n3. Okay, and that's a good sentinel. Not the best sentinel. There is a better sentinel than that. What is a better sentinel? A sentinel is basically something that says, all right, okay, you can't follow me anymore. All right, I'm of this type, but you can't do what you usually do with this type with me. Okay, that's basically what it is. I am of node type, right? I point to a node, but you cannot go into me because I'm the last node. Okay, so you can make that decision in software with Giovanni's technique, saying, well, you know what? If the next node is not myself, then I'll descend into it. Yeah, one if statement, and you can get the effect of Giovanni's sentinel. But if you don't want to do that, and you want to test for something else, what do you do? Right? What other sentinel can you use? Come on, take a chance, take a guess. Like I said, I say so many wrong things in class, and I don't care. Okay, and you should also say a lot of wrong things. It doesn't matter. Okay, and college is not about trying to maximize the number of times you're right. College is about maximizing the number of times you are wrong. Yes, because the rest of your life is where you got to maximize the amount of times you are right. Okay, in college, you have your parents, your teachers, your friends, everybody. You got a huge support network if you're fortunate. Okay, so then you should say, well, in my life, if I'm going to plan my life and I got to make a certain number of mistakes, I might as well make all the mistakes when I'm in college, right? Because later on, you can't afford to make those mistakes. So now is the time you can afford to be wrong, safely wrong, okay? Not stupidly wrong, safely wrong. And it doesn't matter. You can say the stupidest things now, and nobody is going to hold it against you like 5 years when you're a millionaire or something like that. You're sitting on a different planet. Nobody's going to say this guy said something stupid like 300 years ago. Who's going to say that? Okay, we have sitting presidents saying stupid things in different parts of the world. Yeah, so nobody, people don't. Everybody's concerned with their own life, right? They may say these things, but nobody's going to hold it against you. So feel free, okay? Feel free to just be yourself. Nobody cares. You just have to enjoy it. Otherwise, you're not going to see the real power of these things. What other sentinel can you use? I don't care spending a lot of time on these things. because I don't want to keep marching on and on and on, you know, teach you all the list techniques and so on and so forth. You're going to do all that in quest 9 anyway. I don't want to spoon feed you every step of those things, because these are more important, even though, you know, Sean is yawning, it's early in the morning, and I know people are tired, or, you know, but you got to learn these first before you move on to the advanced stuff. And, you know, so that's why I say, take a chance. What should the next Sentinel say? Say something wrong, okay? You can say, you know, thank you.
Can it be null?
Thank you. Did you say N-O or N-U-L-L?
N-U-L-L.
Fantastic. All right. Thank you. Thank you. All right. So what Kaylee is saying is actually the correct answer too, in the sense that that's what we've all decided is the best Sentinel we can use today. Okay. The value 0. The value 0 is a valid address, isn't it? Yeah, 0 is a valid address. Any street will have a number 0 too.
But that means false though for us, right?
Yeah, no. Let's yes. 0 and 1 means false. Okay, but in the context of pointers, right? Just numbers. Don't talk about Boolean values. Okay, Boolean, yeah, you know, right? Talk about integers. 0 is a number. Yes, 0 is a valid number, an integer. An address. 0 is also a valid address, because every street should have a 0 address. Because if I write 0, the postal system, the US postal system, the machinery will still parse it and say this is a valid address. The postman will not be able to deliver it. Okay, so he or she will say, oh, you know, I don't have a house 0. Okay, you know, they'll get confused, but it's a valid address. The system will say it's a valid address. 0 is only an invalid address at the last mile, right? When it comes to delivery, like that, 0 is a valid memory address too. However, we can say that, you know, let's cordon off a legal value. It has to be a legal value, not like other languages. Okay, in many other languages, and we had this conversation in cs2b. One of our students, Ronaldo Peno, okay, we had this conversation on Reddit. It has to be, a Sentinel has to be a data item of the exact same type. Not in other languages, you can have different types. Okay, even in Java, you can have a null return. When, you know, I think C++, you know, the Sentinel is of the exact same type, and it gives you the you know, least number of CPU cycles used, I think, right? Because you don't have to make a type decision before looking at the Sentinel and so on. So we say in C++, the Sentinel is the same data type, but it's, you know, but it's a value that I will guarantee will not occur in the real data, so that I can make my decisions at runtime based on whether the value is equal to the Sentinel or something else. They're all legal numbers, but 0 means something to me, and everything else means something else to me. So far, are we okay? Okay, so when it comes to memory addresses, the value 0 memory address has got a special name called NULL in all caps. Okay, it also goes by another name in more recent versions of C++, NULLPTR, lowercase. You can say NULLPTR right there instead of 0, right? It is the same. So instead of 0, say NULLPTR. All right, that's fine. No. If you say uppercase, it has to be NULL, like Kaylee said, right? That's
Gotcha. So lowercase NULLPTR.
Yeah. And on a comment, you can say, in a comment on the same line, you can say this is the same as NULL uppercase or the value 0. Yeah. Everybody happy with this so far? Okay. All right. Now here's what we're going to do. On the next line, we're going to write a printing method. Okay. So on one more blank line, and we'll say print underscore list, and then let's pass it the address of N1. Okay, address of N1. So open parentheses, and then you're going to pass it the address of N1. Okay.
Gotcha.
Thank you. All right, that's fantastic. All right, a semicolon at the end. Right, and then, you know, you have a blank line and return after that.
It says identifier is undefined.
Yeah, we're going to do that. Don't worry.
Okay.
further down, do you have the return statement and all?
Return?
We can wrap up main. Yeah, clean up. You just have one blank line above return, and that's fine. That's fine. Okay. Now let's go above main and create our function called print list. Yeah. All right. Say void space print underscore list. Open parentheses. And here the print list takes a parameter, does it not? Right? It takes a parameter, doesn't it? So you're going to say that parameter is going to be of type node, and it's a pointer to a node, isn't it? Because we pass the address of node, not node itself. We pass the address of node. So this is going to be node star n, a node star p, node star p, uppercase node star p, uppercase node space star p, space star p.
Was it P?
P. It's just a parameter. We can call it anything you want, right? It's just a parameter name.
Oh, okay.
And then get rid of the semicolon. Get rid of the semicolon space or a space brace there. Yeah, get rid of the semicolon space and then a brace. Right, enter. All right, now we're going to define the function itself. So this is basically going to print out that entire list from the given pointer until the end. So and you can put a comment on above this function that says this will print out the the list. Oh, blank line above the comment, please, because you have the node structure above, right? So thank you.
Sorry.
There you go. Yeah, this prints out a linked list starting at node P. Until the very last node. Okay, all right. So here's what we're going to do. So, and it's going to be so clean and simple that you'll see how easy it is, right? So inside, all we're going to do is, and you have to check this logic out by yourself. And right, so let's try and do this. I was thinking initially we'll do the for loop. We'll actually do it even simpler. So you say while p, right? We're going to say while p. In fact, let's make it clean and simple and say while p is not equal to null. Okay, while p, right? While p space not equal to, and then null, uppercase null, like Kaylee said. Right? Yeah. No, that's it. And then at the end you go and space brace. Right. Now you're going to print the value of p arrow data. P arrow C out left C out. Yeah. P arrow data. P arrow data.
P R data.
Arrow. So this is a hyphen greater than.
Gotcha.
Okay. I think you got the wrong one. Hyphen.
What hyphen?
Where's the hyphen gone? Oh, it's yeah. I was looking somewhere else.
Oh, gotcha. Arrow.
Oh,
wait, arrow, as in like
yeah, like
arrow?
Data. Oh, it gives you the autocompletes. Yeah, data.
Oh yeah.
Data. Right.
Gotcha.
And then what we want to do? Yeah. Okay. And then left shift more on the same line. Left shift more.
Shift.
Yeah, left. One more left shift.
You mean the word?
No, the two less than signs. That is a left shift operator. Yeah. Less than.
These? Oh, like this?
Yeah, that is a left shift operator.
Gotcha, left shift. Oh, left shift.
Yeah. Right. So at the end, we want to put a string comment there. Let's say within quotes, you say dash greater than or something like that, right? Dash greater than. Dash greater than. Dash
like
3 dashes
dash.
greater than. 3 dashes and greater than, so that you don't mistake it for C++ operator and greater than. Greater than.
The word greater than?
No. The greater than sign.
Oh, the arrow. Okay, so gotcha.
Yeah. All right. Now, no new line here. All right, no new line. Enter. I don't know, semicolon at the end, and I get out of the while loop. Now, in fact, because the while loop has only one statement, we can remove the braces. We don't even need to have the braces, right? It's only one statement, right? So after the while loop is done, now what we want to do, when will the while loop end? Oh, I see. We actually do need, I'm so sorry. We do need the braces. We need one more state, one more.
Okay.
We need one more line.
Gotcha. Oh, wait.
Yeah, sorry. Right. Now you want to say P equals P arrow next. We want to say on the next line, you say P equals P arrow next. P equals P arrow next. So this is a magic line. Okay. So this is what it says, print this node and then move on to the next node. This is P, this is, P is next, right? Print the node and then make P this and, move everything. Now you print the next one and move on. Keep doing that until you hit P equals null pointer. Yes, that'll print the entire thing. Okay, all right. Now here, outside of the while loop, you say C out null, C out null, C out left shift null. No, within quotes. Or you can say C out left shift and end of list. C out left shift end of list. Yeah, and then endl after that. And
then,
no, you need an endl after that. Left shift.
Yeah.
That's it. Now, I think get rid of the blank lines after that, and that is a complete function that should run, and it should also print 10, 20, and 30 in that list form in your output, right? So if you click the run button, it will actually run it. And I think if we don't have any errors, and I'm pretty sure we don't have any errors, it should print those 3 lines. That's the thing that it takes a long time to compile and run programs. Yeah, why is it taking so long to compile and run programs on Windows, right? Because these compilations of simple programs like this runs fast. I think even in VS Code, it runs fast. Most of the overhead in Visual Studio Code, I think, even in running small, here's what I think. That is why I said VS Code is better than Visual Studio, okay? Visual Studio Code is good for large projects involving, thousands of files, many lines of code, because there's a lot of overhead that Visual Studio Code takes over, right? Managing the project and setting up the environment, things like that, build and versioning and all those crazy things. That's why even if you try to do a little thing, it takes a long time. That's my hypothesis, okay?
Yeah.
Whereas in all these other things, if you want to do a little program, it'll just do that little program for you, bam, like that, and you're able to make progress much faster. But in big programs where you're going to have to do that overhead anyway, then Visual Studio Code makes a lot of sense, I think. Well, and that's what I think. But whatever makes it faster for you right now, do it, okay? Last couple of weeks in class. So now everybody okay with this so far? We managed to run it, and you see that list up there, 10, 20, and so on. Now I want to be 100% sure that everybody is comfortable with that way of traversing a list. What we did was, if you go back to the code, right? What we did in that print list code was took that list and traversed that list. Now you can write a similar program like print list, saying on the next line, after print list, create another function. Create another function right there after. No, not that. After.
Outside of the
right. Now here's something we do all the time. Okay, C++ programmers, any programmer, when you start creating objects, this is something you're going to have to do a million times in your life. Okay, so we're going to do it now. And here it's not attached to an object, but eventually it's going to be attached to an object when you start creating objects. Okay, this function is going to be called node to string. Okay, so you're going to say string space return string space node underscore to underscore string, node underscore to underscore string. Okay, and it's going to get past a node pointer. All right, and just like to string, it's good. Just like print list, it's going to get past a node pointer.
Okay, gotcha. And then just
all right. So here's one thing, okay? And I think there was a discussion about this on Reddit also. Some people say the star should be stuck with the node and not with a variable, right? The pointer should be at the type, and no, that is wrong. Okay, the pointer should not be stuck with the type. The pointer should be at the star should be stuck with the variable, and the reason is that star, that variable, is of that type. Now, if you have multiple variables on the same type, if I say int star and then x, y, z, then only x is int star. Y, z are ints. Yeah. So it introduces all kinds of programming problems. So experienced programmers know to stick the star with the variable and not the pointer, the type. So and I think I didn't mention this in the forum, a Reddit forum. But it'll play out and they'll discover it and find out themselves. But that is the reason behind putting the star there. So you might as well know. All right, now node star, you want to do, what is it? E? Did you say E? Node star E?
Oh yeah, I just put E. Did you have something in mind?
Node star P. The same as the previous line. So you can say use the same. It usually helps to have the same parameter name.
Oh, okay.
Right now, this is what this function needs to do. And I would like, if you guys don't mind, I would like you guys to write this 5 lines by yourself, right? Not Van, because he's already done it. Hopefully Van will still type and someone else will call out the code and Van types. Is that okay with you, Van?
Definitely. Yeah.
Right. So now what this should do is put a comment above the function. This will return a string on above the function. Put a comment. Yeah. Yeah. Well, okay. No, in fact, put a comment like the previous function, right? Put a comment above the function, like you did in the previous one. Yeah, blank line, and then this will return a string exactly like a print list, except no. Actually, you should say this is exactly like print list, except it will return the string instead of printing it out to cout. This is exactly like a print list, except it will return the string to be printed instead of printing it out itself. Okay, is that enough of a comment for you guys to write it? Can you guys write this function yourself? Because I've done some chunk of it, which should help you. And even though it's simple, it's important to do it hundreds of times like this. Because
so did you say store list or print list?
Oh, exactly like print list, except it will return the string to be printed instead of printing it. It will return a list. Return the string.
Oh, sorry, return a string. Yeah.
Return the string to be printed, not a string. Return the string to be printed. A string to be printed instead of printing it itself. On the next line, you can say instead of printing it itself. Yeah. Okay. All right. So that's a comment. That's what you need to do. You can do it however you want. You can use string stream and add to the string stream and return .str at the end, or you can add to a string and buffer it. Whatever it is. Would you like to do it? Because this is important. You got to get into the habit of traversing a list, because what we're going to do next class is we're going to take this list. Now we know how to hop on that list, because this is how you hop on the list. This is a singly linked list. You can only hop in one direction. Yes. We're in a country with one-way roads only. Okay, you can't turn around. So if you go forward in a singly linked list, you can never come back. Is everybody okay with that? Yes. Okay. So isn't that a problem? Because if you're at a particular node and I tell you you need to go 5 nodes back, you're basically screwed, isn't it? However, we can write a function, right? It just occurred to me, right? And we'll do this either today. What time is it now? We've got a lot of time. All right. So here's what we're going to do. All right. So this is for you to do. All right. So on the next line, you say to do. On the next line, you say to do for students. Right. Third line of comments. Right. To do for comment. To do for students. To do for us, or something like that. To do for us. All right. So let's do one more function, and you're going to do that one too. All right. So one more function just like that, and we're going to say this function is going to be rewind n elements. Right. So string. No. You're going to say node star rewind n elements. Node star rewind n elements. Node
so
star.
I would do lowercase.
And I'll put a comment above this, and you can write it if you want, or I'll come back and write it for you. Okay. Uppercase node.
Okay. Should I put it right here for the second function?
Yeah, both of them. Both of them are to do. The previous one was also to do, right?
Yes. So I'll put
blank line above that. No,
yeah.
above that.
Gotcha.
Okay. All right. So now, and then this one also. So where are you on line 34? Go to line 34. And then you're going to say uppercase node star, node space star. No, lower. Yeah. It's called title case. Space star. And you say rewind n elements. Rewind underscore n underscore elements.
Say n.
n underscore elements, and then open parentheses. You're going to say node star p space star p comma n. Okay, so now what we want to do is space open brace and right now let's put a blank line above 33, and then we'll put a comment 33 and enter.
Gotcha.
Yeah, enter. Right, enter. All right, a comment. Now this wacky function, wacky and inefficient function. You should say wacky and inefficient function. Well, you shouldn't say inefficient, because this is really the most efficient way you can do it, I think. Right? This wacky function to return the nth predecessor of the given node P in a linked list, in a singly linked list. The
Gotcha.
nth predecessor.
The nth what was it?
Predecessor. DECESSOR. Predecessor. SSOR. Right? Nth predecessor of the given node P.
Node P.
On the next line, continue the comment. If it exists in the singly linked list in which P is contained. So we're making a lot of assumptions here. So given saying that node is a singly linked list, it has to be a singly linked list, right? Because it is like that. Okay. All right. If it exists on the singly linked list in which P is a node, in which P is a node. Okay. Now, this is a challenging function because in fact, it is an interview. I think you can use this as an interview question, right? Later on, when you're trying to hire programmers, you can use this as an interview question. How can they find the nth predecessor of a given node in a list? How can you do that in a single linked list? I can give you an idea if you want. I can give you an idea to pursue in code if you want. If you don't want an idea, if you want to try on your own, that's fine. Okay, tell me, that's okay too. But this is a fantastic interview kind question. You can ask this question in an interview. How do you find the nth predecessor in a singly linked list? You can't go back, yes? How do you find it efficiently? How do you find it efficiently? I'm waiting for an answer, okay? And I'll hand over to you after you give me an answer, and and we're happy that you can code on your own. But this is my question: how can you find efficiently what the nth predecessor is?
But you can't go back though.
You can't go back. No, you can't go back.
Could you cycle through? Like, does the list cycle through so you can just go forward until it goes to the beginning again?
No. So if you cycle to the end, you can go back to the beginning, right?
Right. Okay.
Oh, but you can scan it any number of times. You can scan the list any number of times. You can hold on. So and P is given to you, right? Oh, actually, you know what? Oh, bummer. You can't have P. I'm so sorry. I led you down a wrong trail altogether. I'm so sorry, guys. Okay. All right. So you want to say on the first parameter. Sorry. On line 36. Line 36. The first parameter before node star P, you want to say node star list. Right? Node star list, comma, node star P. And I'll also attach the star to the P and the list, not to the node.
Oh, right.
Yeah. And then in the given linked list, in the comment. No, that's fine. What you have in the comment, you can say in the given linked list. In the given, on line 35, you can say in the given linked list. No, there, on line 35, where you say in the linked list, you can change that to in the given linked list because the linked list is not given to you. Yes.
Sure.
All right, so you can get rid of the clean up. All right, so there you go. So you have a list and you have a node and you have the n for nth predecessor of that node. That's what you want. You have the list. You have the start of the list. and you want to find the nth predecessor of that node. How do you find it? Is this not an interesting problem? It's an interesting problem, isn't it? Yes?
Yeah, I'm kind of just, I'm held up because it says we can't go backwards, but we're also trying to find something that causes us to go backwards.
Yeah, but you know, how else can you do it? If you cannot go backwards, how else can you do it if you cannot go backwards?
Go forwards?
Okay, but well, how can you use going forward to your advantage?
Well, because if you said you could scan it multiple times, you'd be able to go forwards and technically just find the predecessor, but by restarting.
Good. All right. Good. Now, let's put one more line of comment. Yes, that's the way. And you should do it. There's one more way to do it, which is kind of cool and interesting and good to show an interviewer that you know multiple techniques, right, to do the same thing. So let's put one more comment. It should return null. It should return null if P does not have n predecessors, has fewer than n predecessors. If P has fewer than n predecessors. Okay, all right. So with that comment in place and what Van said, you are actually fully equipped to do this. Okay. And now Van can guide you to code, but with his idea, right? Or if you understood what Van said, you can also code it and he'll type it in. After you've got it working, I can describe to you one more way, other than, this different from what Van said, because I think what Van said is that you scan the list 2 times. Yes. Scan the list 2 times. And then find the length of the list, subtract n, and then the second time you scan, you can get -5 or -n and stop there and say that's it. Yes? 2 times? Do that. Yeah. Do it that way. I'll show you how you can do it with 1 scan. Okay? If you can do it with 1 scan, you cannot examine an element more than 1 time. Okay? No element should be examined more than. So that is your interview question. So what you can say is, when a candidate comes in, this is basically, this is your warm-up question. It's not like a serious interview question. This is a warm-up interview question where a candidate comes in and say, 2 warm-up simple problems to get them started and start not feel so jittery is a linked list, and then you have to find the nth predecessor of a given node. And then the easy solution, if they're totally stuck, you can say, well, you can scan it 2 times, find the length, and then -n and right. So that they should be able to implement at least that. Hopefully, you'll be able to do that in class. Okay, or I'll show you how to do it. If they can do that, you can say, all right, can you do that now using only 1 scan of the list? Okay, not 2 scans, 1 scan. So that also, again, it's warm up. It's not a challenging interview question, but it's really warm up, but still slightly more challenging than what they started with. Yes or no? Only 1 scan. Okay.
Only 1 scan now? Okay, yes.
Okay, don't do it now. Do it the Van way, all right? 2 scans. Scan it 2 times. And can you do both of those functions now? Can I leave this with you at this point? Right? Because that's what I want to accomplish today. I want you to get 100% comfortable with linked list, hopping around on linked lists. Right? If you can hop around, go from one place to another, find out where you are on the linked list, get your bearings in a linked list. That's enough for us to tackle next week, because next week we're going to tackle, the real, hard aspects of linked lists. Okay, because the hardest thing is making a suture and tying it up so that it doesn't show afterwards. Yes. Okay, so that's why I want to keep that to the very last week of lectures.
Before we do this, I might have a couple questions of these new operators that I haven't seen before, since I missed.
Hey, also on line 11, attach the star to the next, not to the node.
Oh, 11.
Yeah, it's not node star next, it's node space star next. Yeah.
Is that just like proper like syntax, like not syntax?
No. The compiler is happy with both, but let me give you an example. Right? Go right somewhere. Create a comment. Create a comment there. On the next line, maybe. Right?
Where?
So, all right. You say int star. Int star.
Sorry.
Okay. Space. P1, P2, P3. No, P1, P2, P3. 3 pointers. No. So if someone wrote int star to say integer pointer, is this something that they would intuitively write? Semicolon. In fact, you can even remove the comments. We'll delete this line afterwards, right? Remove the comment, let the compiler look at it. It won't complain, right? So remove the comment, yeah, and put it on a line by itself so that we know to clean it up later. We have to delete it, right? And then blank line above that. right? So you see the compiler didn't complain. Yes, no complaints by the compiler. So you can do it that way. The compiler won't complain, but this is really bad practice. Lots of programmers don't know it because the compiler sees things differently than what we humans do. So on the next line, after the int star, you can say, this is what the compiler sees. All right, on the next line, this is what the compiler sees. This is what the compiler sees when it reads line 14, right? Put a comment there. Put a comment there saying this is what the compiler sees when it reads line 14. Okay, on the next line, you say int star p1.
Int star?
No, int space star p1. Oh, you can say int star p1. Yeah, you can say int star p1. You know, like you said before, int star p1, semicolon, space, int p2, space. No, not int star. Now it's int space p2, comma. Oh yeah, semicolon, say int p3. And on the next line, you say, this is what a human being would say, right? On the next line, you'd say, this is what a human being sees. Okay, on the next line, you say int star p1. No, you can say int star p1, like you said before.
Yeah, right.
Int star space p1, semicolon, space, int star space p2, right? Semicolon, int star space p2, p3. All right, right? So now these are two very, very different things, and put the very, very in uppercase on the next line. On the next line. On the next line, say these are two very, very uppercase VERY different things, right? Yeah, comment there. Yeah, comment. That's why we stick the star with the variable and not the type, and say
with the
variable and not type. Instead of type, and say next line. On the next line, you can say int space star p1, comma. Now you know, space star p2. That makes total sense, doesn't it? It says that p1, p2, and p3 are all pointers to an integer. Does it make sense? Comma, comma, space star p3. Now, is this not more readable than what we had before?
This comment line 21.
A semicolon after that.
Then semicolon. Line 21.
Line 21. Yeah. Line 21 is
much more like compared to line 14.
Yes.
Yeah. So if it's int star p1, p2, p3, is that just saying that? So wait. So these are it's all pointers. So like this is what the machine sees, and we're thinking this. So this is not wrong either. So line 19 and line 21 are the same thing still?
No, they're not the same.
They're not the same.
Yeah. The line 19 and line 21 are the same thing because they're all pointers. They're all pointers.
Okay.
Is everybody okay with this? Sean, are you okay? You understand?
And we want to put this by P1 because it's just a nice mental exercise to say that P1 is the pointer because int is really just it's just the type. Okay.
P1 is a pointer. P1 is a pointer.
P1 is a pointer. Gotcha.
That's the reason. And you know, you can see, you know, experienced programmers usually don't do it this way. All right, so let's get rid of that int star p1 p. All right, you know, put that in comments too. In fact, make the line 14 a comment and bunch it up with the rest of the comments under it. So that's fine.
Gotcha.
And then you can put a comment right above that saying the site digression not connected with the main project, or you can just delete the whole damn thing. It doesn't matter.
Okay, gotcha. I think I'll leave it because it looks kind of handy for me. All right. Okay.
Okay, all right. Now, are we good so far? Can you guys now implement those two functions? The first thing to do is do the print function. Did we finish the print function? We finished the print function. All right, do the toString, note to string, which should be really easy because it's very similar to print string, except you're going to return the string. Yes or no?
Yes, return string.
And then when you've done that, do rewind n elements, which I think is a good question to prepare you for interviews and also to give an interview when you can ask a good question that the candidate would love to solve. Okay, because don't give them stupid as boring questions and neither you would like to ask or the candidate would like to answer, right? So these kinds of things would actually jazz them up and get them excited about doing something. It's more interesting. So that would be an interesting warm-up exercise for people. Okay.
Mhm.
Is everybody okay with this? Can I just turn the laptop around and can you guys code? You got to keep vocal and talking to each other. Okay. Can you guys code? Can you guys code those two functions? Next week, we'll talk about suturing. Okay. Grabbing an element and removing it. Okay. That's very dangerous, isn't it? That's why it's very at the very end. But that's all you need to know, I think, with linked lists. You need to know how to do that. And also rewind, you have to know it's inefficient to rewind, okay? And you need to know how to take something and get rid of it. Because everything else is the same. Cutting and things like that. Everything else is the same. Yeah?
Yeah.
And then next week, after we do that suturing thing, the cutting of a list, we can also take a look at interesting things. If I give you two lists and you have to find out the difference between the two lists. Meaning, all right, if the two lists are the same, if the elements, like two strings, how many characters are different? Okay, like that. We can do two lists. How many nodes do they differ? That kind of thing. All help you in just getting practice in manipulating lists. None of these is a test or an exercise. Okay, every problem you get with linked lists and trees and things like that, they're all meant to give you practices, like in music. Problems, slightly more and more challenging pieces so that your fingers just start getting muscle memory. Yes? Long range reaches and so on and so forth. That's not initially practiced, right? You just want to get the close by keys first.
Yes.
Yeah, and then eventually you want to say, okay, I want to learn some, Tchaikovsky pieces or something like that. All right, and then you get to these movements will also have to get precision now, right? And things like that. That's what linked lists and tree problems and graph problems do, right? None of these is a test. You don't have to master these algorithms. It's just practice to get to know how to navigate so that once you know how to navigate, you can come up with these solutions yourself, okay? The goal of mastering all these algorithms with lists and trees and graphs is not to learn these algorithms, is to get comfortable with this data structure so that when you get a brand new problem, you can just tackle it yourself and say, well, I'd be using this. And it'll borrow the same techniques that you'll see in Dijkstra's algorithm or Kruskal's algorithm, all the same techniques, because they're all using the same techniques, just put together in different ways. How do they come up with this? They just have to get comfortable with the data structure first. Once you're comfortable with the data structure, you can just do, essentially, isn't it? If you go to London, right in the middle of London, and you have to go to some address, you know how London is the most unstructured city in the world, I think, right? So it's impossible. But if you get into a taxi, and you tell them where you need to go, they will know the most efficient route in a fraction of a second, even before Google can find it. I think, I don't know. So they manage to have this magic memory of the geography of London streets like that. How do they do that? How do they do that? They don't memorize every single thing, but they know how to find these efficient things, and that's because they are comfortable, 100% comfortable with the geography of London, right? They know the nooks and crannies, and if you want to go from one place to another, they'll tell you, even things that are not on Google Maps. So that way. But that's the same thing with data structures too, right? If you're 100% comfortable with the data structure, then you can do magic with it, right? And people who come in there and say, I want to get this done, and you say, yeah, no problem, I can get it done, and it'll be mind-boggling. right? Because you know your area. But a lot of people say, I don't want to get to know my area. I'll just learn a lot of techniques to deal with it. They'll never get to know the area. Okay, they'll have to just learn millions and millions of techniques one after another. And they're not, well, they'll have their place. Let's put it that way. Okay, but if you get to know the data structure, you don't need to know the millions of methods. You can just come up with them. You pull them out of air. Right. So anyway, I don't know if that's right or wrong. You got to find out yourself or prove me wrong. But there's enough blabbering for now. I think we have enough time for you guys to code. All right, half an hour. So are you guys okay with coding right now? Yeah. Nobody's even nodding. Okay, so I don't know. I don't
Sorry,
know.
I turned the camera off for a second.
Van said he's okay to volunteer.
Yep.
Okay, he's volunteering to type in. I need one more person to call out the code. Okay, and other people can also jump in and correct and brainstorm together. That's all great. Honey to my ears. But one other person, please, should tell Van what he needs to type. Can someone volunteer? You can also guess together. That's fine. One person just needs to be brave enough to say, I'll use my vocal apparatus. Okay. And you could even say, random things like rabbit, elephant, and things like that. And other people could say, no, it's not rabbit, it's actually open brace. That's fine. Okay. So you can say whatever you want. But someone has to volunteer to be brave enough to speak, like me. All right. And then other people will just back them up. Can someone please volunteer to call the code out that Van has kindly consented to typing for us? It doesn't matter if you're not confident. Okay, it's okay. You'll get confident. You'll get comfortable. That's the whole idea. We're not. See, the thing is, you haven't been hired in as employees and tasked with a job that you have to do. So why do students have this impression that, oh my God, I lose my paycheck if I don't do this, right? I got to pretend to my manager that I know how to do this, and I secretly go and find out later, or ask someone else. No, that's useless. Okay, you're not being paid for a job. You're here to learn. Nobody is ever going to hold it against you if you're mistaken, because you went to a shop trying to find candy, and if you don't like candy, okay, there's no problem tasting it, right? Ice cream shops give you tasters all the time. Yes. So you're a student. You should feel free to just taste everything out there. Say wrong things.
You probably just
to get be wrong, okay? Otherwise you're never going to be brave enough to be wrong out there if you're not brave enough to be wrong as a student. So can someone please help us by saying to Van, I'll call out the code, you just have to type. It's okay to be wrong, because if you're totally wrong, you say, hey, I'm stuck, prof, can you come back and guide us more? I'll be happy to come back. Okay, but I just don't want to keep going on typing, calling more stuff out, and Van types it, and the rest of you are totally lost, and then there's just the two of us, right? It's like a one-on-one class. So I don't get any feedback. So this way, if you guys just jump in, at least I know, right? I need to come back and give them more guidance, or give more information, or go faster or go slower. I don't get any kind of that information, right? So if one of you can do that, that is what you would be. You can consider that your contribution to the teaching or learning, because teaching and learning, they don't go separately. Okay, they got to go together. I can be teaching to thin air, and you can be learning from, well, you can technically be learning by yourself, but teaching definitely needs a student, I think. And so if I'm just teaching to thin air, then there's no point, right? I don't have to invest as much energy. I can just put the notes in front of you and say, go and learn. Can someone please guide Van? All right, and call me.
Professor, I could probably just start coding, and we could just kind of just jump in any time.
No, I don't. Then it'll just be you, Van. I fear that it'll just be you if you start coding.
No,
Okay.
no. I mean, like, it's like a gradual thing. I'm just
okay. All right. So you believe you can coax people to start participating?
It's just.
You can try. You can try. The reason I was reluctant is because there's only 10 lines of code, right? And if they jump in on the 5th line, that's if you're going to start. Yeah, there's not a whole lot of code for people, and we don't have a lot of time. Okay, how about this? Start coding. Please be brave. Okay, be brave. You'll be proud of yourself later on when you look at this YouTube video 10 years from now, right? You'll say, I'm glad I was brave there, because that's the reason I was able to stand up here and make this presentation before the corporate board. And I had, I said, this is wrong. This is not our direction. That our company should be investing in this, not that. Right? And it's okay. And someone would say, no, that's wrong because, and then you say, yes, I'm sorry. Okay. And people appreciate you for that because you brought a perspective which was useful, even though it was wrong, and you admitted, right? So, but you never get to do those things. This is all practice for that. Okay. Can I
got a
check?
question. Sorry.
It
has to do with the whole asterisk and pointer direction stuff. What does hyphen greater than do? So what does the arrow do?
Yeah, all right. So hyphen greater than is basically just shorthand for take the pointer that's attached, take the pointer, and from the pointer, go to that element. Let me phrase that in one other way so you will understand, okay? Go on to the next line after 27.
Next line after 27. Like which one?
20,
open up
27. End of 27. All right, okay. Actually, go to the next line after that better.
You mean put a space?
No. I meant, put it back to where it was and create a new line after that 27. After 27.
Oh, after 20. Gotcha.
Yeah. And then open a comment there. Equals, is a space. P equals a space equals, and then within parentheses say star P. Within parentheses,
gotcha. Star P.
Close parentheses, dot next, semicolon. Right? And then further down on the same line, you say this is the same as the previous line. This is the same as the previous line. And I'll explain it, then you can noodle on this before. Same as, right? So arrow, you can read up on the, if you want, but I'll just give you the gist of it. Dash greater than is basically just shorthand for go to the pointer and go to that element inside of that object. So you say star P dot next. P is a pointer. P is a pointer, yes?
Yeah, there's a point. Okay.
Star P is the contents of the pointer, which is the object node.
Gotcha.
Object dot next is from the object.
So that's kind of like the same way of just saying like int variable is equal to, or it's more like variable. Sorry, hold on. It's like you have an integer variable and inside is like dot data. We can do the same thing, but instead of calling.
No, you can't. You can't do that in C++. How can you do var dot in C++?
Oh, the dot. I can do that in MATLAB. Never mind. I kind of just.
Yeah. So even in MATLAB, var needs to be a complex object. For a primitive type, you can't do a dot. I think dot basically means.
Oh. Okay.
Right? So
gotcha.
Dot basically means go inside the object and extract that one field from it. That's what it means. So go inside the node and extract data. Dot data. Go inside node and extract next only. That's dot next.
Got it. So
okay?
Extract it like the same way that you like a variable, like it houses a variable or it houses something. So access it. So access whatever it's housing.
Yes.
That's what.
In fact, we have it. So that's why in classes we have getters and setters, which we don't actually have dot. We say dot get and it'll go and get it for us. We didn't go down that road because I didn't want that confusing linkless concepts. That's why we're just doing linkless here. Okay. So so star P is a pointer. P is a pointer. Star P is the contents of the pointer. So instead of doing that, crazy braces and parentheses, star, dot combination, which is kind of crazy, right? Too many shift. I say there is C++ gives you a shorthand and say, and you can say if P is a pointer, instead of doing that, I can basically say P arrow. It's basically the same. It's exactly the same. Does everybody understand so far? Is everybody okay with this?
That makes sense. That makes a lot of sense.
Synonymous, okay? They're exactly the same.
Okay.
All right. Is that okay now? Can you guys code? Any other questions? Any other questions?
I think.
You can leave the comment there if you want, because if people look at the code.
Oh, sure.
When you share it on Reddit,
Yeah.
Professor?
Yeah.
So is oh my gosh, I can't. Is P arrow data like similar to like P like get contents?
P dot get, but we didn't define a get contents. Did we define a get contents for?
No.
Where did we do? Where did we do get contents?
No, I just know like you can like create, you know, like get like it's basically just like getting the value, right?
Yeah. So for
Okay.
I'll just put in a comment, right? So go to your node structure, go to your node class, go to your node class. Yeah, right on top. You can actually put under public. You can actually put under public, under public, under node star next, under node star next. The blank line, one more blank line, one more blank line. Yeah, and we're going to do what Kaylee said. So we're going to create, so put a comment, say a function. Here is a function. Here is a function. Here is an example useless function to illustrate a point. Example function to use, function to illustrate a point. On the next line, you say get, illustrate, illustrate, a point, right? On the next line, you're going to say int, no, you just say int, space, get underscore 10 times, so, or 5 times or whatever, say 5 times, 5 times underscore data, open close, and then on the right, open brace space and then a brace right there. Yeah, even there is fine. Return 5 times data, semicolon. No, 5 star data, semicolon. Semicolon. That's it, right? Now, here's how you would call this function, right? So on the next line, after you put a comment at the end of line 13, hit enter. At the end of line 13, hit enter. Right? Here is how you would use this. Say, put a comment saying, here is how we use it. We may use it. Yeah. All right. On the next line, you say, comment with a node space my node. My underscore node. Semicolon. Enter. And then a comment, and then a my node arrow my node dot data equals, I don't know, XYZ. Yeah, space equals XYZ or whatever, some, semicolon. On the next line, you're going to say int my val equals
My val.
equals my node dot get underscore 5 times underscore data, open close, semicolon.
Get underscore.
Get underscore. Kaylee, does this answer your question?
Yeah.
All right. Is it get underscore? Is it get parenthesis?
Get underscore, 5 times underscore data. This is the function name. You got the function name on the next line. Open close, open close.
Oh, right.
Open close.
Yeah.
Semicolon. Semicolon. Okay. So Kaylee said, here's a node and you have the dot data dot. You're accessing a member. Using dot, you're accessing member. You can access member functions in the same way. So get 5 times data is a member function. Just like a member, it's a member function. And it belongs to the package. It belongs to that node object we created. Yes? So when we create a node saying my node, you can access my node.data, my node.get some function, right? You can access all of its members in exactly the same way using the dot or the arrow if you only have a pointer to the data. Now, I know, not just from your reactions, okay? I know this is slightly challenging to sink in, especially if you're being exposed to this for the first time in C++. Pointers, addresses, dereferencing is the hardest part, okay? So the important thing is not to rush this, okay? And say, because, every week in cs2a, you have, 2 weeks worth of material, 2 weeks worth of material, and so on, right? Or 1 week, or, a few days, and so on. 1 week, let's say 1 week. And you may think, okay, we have pointers and addresses for 1 week, and therefore it's got 1/12 of the importance of this class. Natural to think like that? Okay, unfortunately, that is not correct. Maybe I should just make this in my syllabus very clear, because this is not 1/12 of the importance. This is like 9/10 of the importance. Okay, the first 11 of everything else you've learned so far is only building up to this. This is what you need to learn for cs2a and for C++. And so if this takes longer, don't penalize yourself and put yourself in a tough spot saying, I only have 1 week for this. In comparison to all the other material that I had 11 weeks for, I only have 1 week for this. That is the stupidest thing that we could have ever told you. This is what you have 12 weeks for, essentially. So if it takes you longer than 1 week to get to the solid rock core bottom of this, you should take that time. If it takes you longer than the finals, that's fine. Okay, but getting 100% comfortable with pointers and linked data structures is the beginning of your adventure into computer science. It's really the beginning, right? So far, we're only showed you all the gear in this, ski shop, right? You can buy this, you can put these boots on and this jacket and glasses. Okay, got all the gear together. Okay, now when you learn about pointers and how to manipulate pointers, that is when you're going to start hitting the first slope. And then you start getting to say, all right, here's a tree. I don't want to run into the tree, okay? And here's a pointy object. I don't want to get skewered by the pointy object. All of that, when you get the gear, 2B will teach you how to do that, okay? In 2C, you'll basically be, whizzing down and up and down the Alps. All right, new experience. I hope this was useful to you. Do we have one more week? Week 11. This is week 10.
Yeah.
Okay. So I'm comfortable.
Oh, speaking of week 11, yeah, right. So I was asking the Reddit. I don't know if you talked to us before about this.
You guys are not at all, not as active as I would like on Reddit. Okay, look at all the previous quarters and see how active people have been and helping each other and on top of things and discussing technical things. And you guys are like totally silent most of the time, except for a few people who do ask, and then nobody responds to that, and it just languishes and 0 votes and no views and dies after that. So I don't know what's going on. I have to think, look at ways in which I can, keep the life in this community, even when I'm not around. Because when I'm here, some of you get together and some interaction that's forced by me happens. But that should not be the way, because I'm not going to be stuck with each one of you for every one of your years of life. Okay, this is it. Unless you do 2B and 2C with me, even then, that's it. After that, you're on your own. So you got to learn to interact with all the other students. Maybe you're doing that already, but unless I see that happening professionally in C++, how can I be confident that if you become a data engineer or a scientist or who's learning using C++ in real life, how can I be confident that you are someone that I or a friend or someone who asked me would be happy to use? Yeah. So you should take advantage of these things. And I just keep talking about this all the time, but nobody's really taking advantage of this, right? So keep the Reddit alive. The code, we'll take this next class again. Okay, what time is it now? We're probably past time, 9:50. Kaylee already has to go. But hopefully your next class is not far away because you're already in PSAC, yes? Okay, yeah, we'll talk about this again next class, but that is really super important. Get all the other students to come, okay? If you don't master pointers, don't do CS2B. Not with me, not with Mikhail, not with Dave. No, don't even do 2B. You're going to make their life hard. You're going to make your life hard, and you'll have a bad experience and come out with a bad grade. You master pointers and then go to CS2B, okay? Mastering pointers just doesn't mean knowing how to do it. Knowing how to do it is 10% of the equation. But playing with it after you know how to do it, looking at it in different angles, right? Looking at it and saying, oh, well, that's how it look at from this angle, that angle, this angle. Okay, I can do that, this, and I can work all this magic. Okay, so how do you get to know that? That takes a long time, right? I don't mean 10,000 years. I mean that you just have to set apart, let's say 1 week of only food, drink, and coding. Okay, this is my retreat, coding retreat. Maybe I'm not going to succeed. I'll try something else. I just want to keep finding as many different ways in which places where I can use the linked structures, so that I just get familiar, right, with different ways of you doing it. Because people who just learn one way of doing it will pass the exam, but they won't get a good job. In order to get a good job and do something that you really love and interest other people in what you're doing, you need to know many ways of doing the same thing. And that's why practice is important. Does that make sense? Okay, all right. I'm going to leave it with you right now. It's at the end of time. Really, you guys never, I was talking the whole time, and Van kindly offered to type for me. So at least my wrist was spared the effort. But you guys should be coding more, okay? We only have 1 more week. And I hope next week, you guys will do a lot more coding, okay? Hopefully after the first 10 minutes, I set it up and I give it to you. And then after that, all I hear is just your excited voices telling each other, let's try this, okay? Can I hope for that next week? Okay, get familiar with pointers. Nobody's even nodding, okay? So I don't know what the enthusiasm level is right now, but you guys should try, okay? Otherwise, you're not, it is very hard. It is very hard to pick this stuff up. I'm not kidding, okay? This is subtle. There's lots of subtle detail here. Thank you all so much for your time. Can I just stop the meeting now, or do you want time to hang around and talk to each other for about 5 or 10 minutes?
Oh, I had a couple of questions for you about the midterm.
Yeah, sure. Go ahead. Go ahead.
Okay. Well, is it going to be open on Monday morning or something, or is it a set time?
What?
Oh, we did the polls. So for the data representation in the midterm.
Nobody voted. I only saw 3 people said, yeah, okay, maybe good to have another crack at it.
Oh yeah, you said you needed 2 votes, and we had like 4 votes, I think.
Okay. All right. Okay. All right. All right. So one of you just send me an email, and as soon as I get the email, I'll remember to open up the.
All right. So I'll work on. I'll send you an email right after we log on.
All right. Okay.
To formally request. Okay. And then I guess if since the lecture's over, I had a couple questions about Visual Studios. I don't know if I'm still sharing the screen. So here on source 3, I am trying to get this to be a part of this whole project. Right now, I just opened up.
Oh, I see. Okay. All right.
Yeah,
so click on
so
the file.
click
on the file. Where's the other source file? Source3.cpp. Where is it?
Yeah, we got March 10, which is the one source file. And then it says
Where
source 3.
Is it in your package explorer? Where is it?
Oh, it has not appeared yet. I don't know how to, because I have.
So what you have to do is you have to locate the file somehow. Okay, and then in Visual Studio, under build, go to project.
Project, yes.
Maybe something called add new file or
add module.
No, add new item.
Right.
Yeah, I think add. Yeah, you can navigate. You can navigate now to your file. Oh, actually, no, new, not new. Add existing. You got it. Add new means it's going to create a brand new resource for you. Kill this.
Okay. Let's actually, since I did it through here, because what I did Control N, which just pulled a random file. But this, let me try doing this one too. More the merrier. Oh, so it adds it directly if I do it. So good. Okay, so if I want to add a blank one, I could just do that. But add existing, you said? So add existing item would be.
Now you could go into your Explorer. You can discover where the other file is.
Gotcha.
And then double click that and it'll add it to your project.
Gotcha. Add existing.
Yeah.
Well, if I'm trying to get source 3 right here that I just started missing.
You got to locate it here.
Oh.
You got to find out where it is.
Oh, I don't. It doesn't look like it exists inside.
No, it's there. I'm pretty sure it's there. You can find it just using search. You can just, where's your Explorer? If you go to Explorer and type search, it'll find it for you.
Explorer?
Windows Explorer.
Yeah, I mean, I just didn't like download it yet, I think.
No, so, Windows, just Windows. No, not browser and all. Just Windows. Just your Windows menu. The Windows menu at the bottom left.
Bottom left right here?
Yeah, that should have Windows Explorer. It'll bring up a window called Windows Explorer.
Sorry,
Microsoft Windows Explorer. No, this is not.
Yeah. Oh, like you mean bottom left right here? Or?
No. It's part of Windows, not part of my Visual Studio. You're still in Visual Studio.
Yes. I don't know if you can see my cursor, but this is.
Oh, actually, hang on just a sec. I'm looking at a Mac screen, not a. Is this Windows or Mac? Oh, it is Mac. Oh, all right. Click on the at the very bottom, bottom left, even more to the left.
This is a Windows, by the way.
Okay, all right. No, search. No, click that again because this is a new interface.
I don't know if you can. I don't know if you can hear me, but on this.
Right now, you want to look for a file. Where do you look for a file? This is how I search the web. Can you?
Yeah, looking for a file. Yeah, so like this is my file directory. I am.
Yeah, that's what I wanted. This is what I wanted. The file explorer.
Gotcha. Okay, gotcha.
So there should be a search somewhere. Okay, search quick access. Right. Type source3.cpp.
Source 3. So I did not download it. That's why it doesn't exist.
No. It doesn't. You don't have to download it. It's in your Visual Studio. Yes.
Nope, not yet.
Oh, it's not in your Visual Studio.
Yeah, it's nothing. It's currently just existing in like current time. So I have not saved it. I have not saved that.
If you haven't saved it, it's not going to be there. But if you've saved it, you'll see it in your Explorer.
Yeah. So I guess I have to save the thing first. So I have to just
save it.
Okay. How do I forget? There's some big button.
Just stick some junk in there. Just save it.
Okay, and then save. Is there what Control S?
Save it. Can Control S.
Okay, perfect. Okay. So save it under March.
No, you can save it anywhere you want. Yeah, okay.
Okay, I'll just send it over there. And then project add existing. That does not look fun. What was it? What was it? Repository. Source 3. Add source 3.
Oh, it should. Why is it not showing source.cpp?
Yeah, good question.
No. It should. Something is. Wait a sec.
Well, it's actually not that big of a problem because I found a way.
No. How do you? It's pretty. Yeah. Well, let's not waste your time on this. But all you need to do is if you just Google how to add an existing file into Visual Studio Code, the very first link will tell you, right?
Yeah.
It'll basically give you a YouTube video showing you exactly what we're trying to do here. Because click on file existing, but I'm still surprised why it didn't add.
By the way,
that file again.
The one that I created, I could find that it's connected through this little dropper. So Control F2.
Hit Control S here first. Hit Control S because save mar10.cpp.
Gotcha. I saved it here. Yeah. So
No. Yeah.
Wait, which one are you talking about?
Okay, kill that. Click on mar10.cpp. It's got a star against it. And save it. Control S. All right, good. That's saved. Now go to your source4.cpp. And just type in some junk and save it for now.
Gotcha.
And hit Control S. Okay. All right. Now source3. And what do you call it? Source3.cpp or source4.cpp or source4?
Just source4 and it saves as a CPP.
No, you got to save it as a source4.cpp. Okay. Now save it. And now add it.
Yeah, source4.
Yeah. It still didn't add it? Okay, open up source folder. Your source files folder in the package explorer. Open it. In the package explorer. To the right.
Right here.
Oh wow. Okay. All right. I don't know. I thought it'll show up here. Maybe this is just showing you the folder, not the it's just solution. So it should show it to you. Hey, Van, I don't know right now. I'm not too worried though, because I'm pretty sure you'll find the answer with 5 minutes of searching. Okay.
No, it's no problem. I mean, the fact that we were able to create one, what was it? Oh wait, okay, now it's gone, but it was somewhere here. Yeah, a new item. This was the big thing that I was looking for.
Yeah. But you should be able to add existing ones too. So I don't know why that's not happening.
Yeah. Okay, but that works. Gotcha. Okay. I I think that pretty much wraps up. Oh, wait, sorry, one last question. So I have multiple files in the same project. I just found out that one project can only contain one main. And
You
if
should
I
only have one file that contains a main.
yeah, so we have march10.cpp, which contains the main, and then I have stuff like source, and I can rename it to other stuff. But
Those guys shouldn't contain mains.
yeah, it should not contain mains. But I could just do something like a method, a method
Yeah,
per tab.
totally. Yeah, you can
Okay.
define methods in there. The only catch is that these methods need to be declared elsewhere because main wouldn't know that these methods exist otherwise.
Right. So would I then declare them in main, and then I could just mess around with them in their respective files?
Yeah, once you declare
Okay.
the header, the declaration of the function is known to main. You can go to the source file and change the definitions however you want.
Right. Okay. So if I include all of the stuff in the header, do I have to include the include header for each
Yes,
file?
you have to do a hash. It's bad practice to put all your source code in the header. But
Gotcha.
if you do, you say hash include that header file in your source file.
I see. Okay, that should be fine.
Yeah.
Okay. And then if I were to, so I have multiple files and I have one file with a main. When I submit this can I submit the whole project to the question
No.
site?
You've got to submit only the files that the spec says you need to submit. Basically, just the CPP files and H files.
Okay. So that would be that would be fine if I submit like multiple files and a header file.
Yeah, you already have to submit multiple files for Quest 4.
Okay. Oh, I mean, like I've submitted the header file, and then I had this one big file that contained all of them inside for Quest 4. So I didn't know if I had to contain all my functions and methods in this one file, excluding the header file, or like if Quest 4 was a 7-parter, I was able to submit 7 files containing a method per file each, and that would have not like had any
Oh,
errors.
you should put ideally you should put all of them in the same file called looping functions. In fact,
Right. Okay. So that's what okay. So I'll make sure to like also make it a good habit that despite me messing around with multiple files, when I submit, I just submit one big file.
Yeah.
Okay, that's good to know. Okay, so that's pretty much everything.
But you shouldn't always do big files, but you should put grouped, similar related functions in one file.
Okay, that's good to know. Okay, thank you.
Yeah.
Well, that should be it for me then. Thank you.
All right. Feel free to organize lectures if you want, but otherwise, I'll see you guys on Tuesday.
All right, sounds good.
Thank you. Bye.
All right. Thank you, June. Bye.
Have a good one.
You too.
Thank you. Thank you.